Hey everybody, it's Tim here. My name is Tim Clicks. I'm on the planet to build a better planet, and I am absolutely thrilled to bring you a little bit of Rust to your weekend or to your week. Sit down, relax. We're going to learn some Rust, and we're going to do that by learning a lot about how the web actually works. So I thought it would be kind of fun if we sort of unpack, or let's say unwrap, web frameworks and try and have a go at like building one from scratch. Like that seems like a perfectly reasonable thing to do. I do not know how far we're going to get in the stream. So we might get something that is really wonderful to use. We probably won't. But we will have learned a lot of Rust. We will have learned a lot about the web, and you would have had a good time. So if you are watching the recording, please do hit subscribe or follow, and there will be regular streams coming online. If you are here live, please introduce yourself in the comments. It makes a huge amount of difference to the sort of vibrancy of the event. And yeah, I am like really pumped to get started. And allow me, oh, sorry, I'm just going. So if you haven't been able to like see how these work, sort of these live streams, as you post comments, I can do things like pull comments up onto little blurbs. And this is absolutely fantastic. For those of you in different time zones and so forth, feel free to, if it's very late where you are, feel free to close. The recording will be live for you to watch at some other time. Okay, let's start looking at some code. And so the first thing to find is I wanted to sort of demonstrate to you what the Conrads Text does not want to be hyper. It just wants to be plain text. This is a weird in-joke from my Discord server. If you would like to join the Discord server, please find my YouTube. There is a link in there, and to actually join it, there's about 1,000 of us, and you're very welcome. And let's make your text hyper. Okay, so one of the weirdest things I found was an example of Rust and from Rosetta Code. So Rosetta Code is a wonderful website that demonstrates a large number of implementations of common code. Sorry, like common problems in multiple programming languages. And this was in some sense, the simplest web server that you can write in Rust, except for the fact that I found an old version that worked with pre 1.0 Rust. So this would have been written in about 2014. And it's really interesting to see how Rust has evolved and become a little bit simpler. We start with our main function, and we have this TCP listener thing. We bind to an address 000, which is code for all addresses, and then a port 8080. Our server listens for connections, and then for every connection that our TCP listener receives, we spawn a thread. And that thread has one job, that is to handle a client. What does handle client do? Well, further up here on line 28, we read from this TCP stream, and then we write to the TCP stream. Now notice there's essentially no business logic in here. There's no ability for us to customize which resource we're trying to access and so forth. And that's our job now as people who are learning Rust. But the read is slightly manual, it's slightly clunky. First, we start off by initializing a buffer of 4 kilobytes, so 4096. It might actually look like this in hex. Is a 4 kilobyte stream, a 4 kilobyte space for data. We call read, and ask the TCP stream to just insert bytes into the storage location that we've initialized. And later on, if everything has worked okay, we get to the end of the read, and this is actually the number of bytes that we've read. And then there's a conversion step where we try to create a string from the buffer. So the buffer doesn't actually know anything about encoding. Because this is HTTP, we might be sending images over the wire, we might be sending video or like a live stream. In fact, live stream uses a slightly different protocol, but let's ignore that for now. We might not actually have valid text, or the text might be in some other encoding like Latin 1, or there's no requirement actually to use what Rust requires, which is UTF-8. Once we have our request, we can then print it out. So this is essentially, that's the read side, and then we send a write out, and this is slightly difficult to read. But this is what your server is sending back all of the time. We send back an HTTP, the version number that we are supporting. In fact, I want to reduce that down to 1.0. The real difference between 1.1 and 1.0 is that 1.0 connections will close at the end of the response, whereas 1.1 added support for connections to be held open for subsequent requests, which we don't really want to support. We tell the server that we are going to send back HTML. So we provide a content type and a charset, which tells the server, the client, which encoding we are sending back. So we could, if we wanted to, describe our text as ASCII, because we only have ASCII bytes in our body of our text, but also we might not. You'll notice that I'm deleting the new line characters, and that's because I want to avoid sending them twice. In string literals like this, the new line characters are inserted automatically because I've actually created new lines. On Linux, which I'm working on, I don't need to, I don't actually need to specify, the new lines are actually part of the string literal. Essentially, going down to the next line is the new line character. Now, we can also add another one, which is content length. And we are sending 37 bytes. I think that's right. So we're sending hello world inside HTML. There's another way to make this more sophisticated, but at the moment we are doing the very minimal amount of work. And on the right here, I have a terminal. So if I just check where I am, I need to, so I've got my little example, and I'm going to create another thing. So rustc example.rs, and then I want to execute that command, which will be example. So our code compiles, and then we listen for connections on port 8080. So now on curl, if I ask for -i, which is include the headers that I am sending to localhost on port 8080, I see I immediately create an error. So that's not great. Received 0.9, we're not allowed. What have I done wrong? I need to figure this out. Now, what have I done wrong? For some reason, I have... When did I send? I'm going to just add the -v. I need to get away from this very, very quickly. So I send 1.1 and then received that doesn't make any sense. So I've immediately broken something. So this was the problem with me touching my example code immediately prior to coming on stream. First new line. Aha! Thank you so much, Conrad. So Conrad saved my day. In order for something to be valid HTTP, the very first line actually needs to start with the version number, HTTP 1.1, and in our case, we wanted to downgrade to 1.0. And now our code should work. I need to recompile the code that I have. So rust C example, and then run the example. We'll improve all of this very, very soon. And then, contact length, I've read some excess data, but the hello world there is, I may also have too many, I do actually have too many new lines before the body, but which is actually confusing the system as well. But that should still be fine. At least we get back a response from the client, which you can see in the very bottom right of your screen. Hello world is actually being sent from my little baby server to the client, which is all very well. Now we want to add some sophistication. There are lots and lots of ways to do this, and one of the things that you may discover very soon is that although the web seems like a solved problem, people keep finding solutions for something that has been around for actually 30 years. And let's try and find out some of the trade-offs that they are creating, and also let's teach ourselves some Rust. Okay. So I want to start by creating a little web framework. Ruby on Rails is is I suppose quite a neat role. So cargo is the what was I saying? I was going to say I need a name for my framework, and I'm just going to call it Steam. Maybe Steam Train, because we aren't going to create the fastest. We're not going to create the fastest framework in the world, because we're going to be introducing a large number of inefficiencies to hopefully simplify the process of learning. Now, inside Visual Studio Code, when in order to get the syntax highlighting and so forth working correctly, I need to add the new folder that I've just created on the right into the workspace. So now I have far less of my code, but I can bring this through. Where should we go? I want to start potentially by creating some sort of type which represents a server, and the server and also struct response. Will I implement MVC? No, not in the 45 minutes or so that I have available. We don't have enough to have something which is very, very polished. We are going to be able to essentially have the very basics. We hopefully will be able to dispatch to different resources. And where can I find theory about this? I think the best solution right now will be to go to I'm just going to add a comment. So my github.com/TimClicks tutorials, and then I'll just add this to the banner as well. So I think the best place to go is here. If you go to my tutorials page, you'll be able to find the code that I will be posting very shortly, and hopefully this will also provide a little bit of context as well. Okay, let's get on with some code. So in essence, HTTP is a stateless protocol that involves two things: some sort of client, which is so this is end user. Server is the computer hosting the the web app, and we have a request. A request is sent from the client, and a response is sent from the server. We're not going to be able to have enough time to really create very nice types or a lot of work, but in essence, our what we want to do is have a server which has a method new, which takes a path. Inside it, there is a TCP stream. And in fact, let's do the listener there. And we'll just actually, instead of saying it's the stream, I'll say it's the connection. And I'm going to just use string, and then we return back an instance of server. If we go back to our example code, we are going to copy out our initial code. So this is TCP listener. We're binding to the address, and in fact, we'll change this from path to address. And we're not going to worry about ports for now. We can just assume that people are always sending us nice ports. I'm also not going to worry about error handling. If you send in the wrong data, the code here will crash. And we're doing that intentionally to say that if you provide invalid data at initialization time, then you should fix your problem straight away, because it's impossible for the code to kind of carry on with an incorrect address. There are other reasons why things might not be able to work. For example, if some other server is already listening on that port, then you don't really have the ability to create another connection on the same port. So the syntax for creating a new type is a literal form. So we use these angle braces. This is not listening, this is listener. And now my new method can be called, and I'm just going to add, actually, and so this is going to be 000. It looked very, very familiar on port 8080. I want to re-implement the behavior that I already had in my example script in a way that is a little bit more friendly. So there isn't much difference now. We have server, and then inside that I have a connection which represents the TCP connection, and then I need, let's say, incoming, although this is a bit strange. So we'll stream an incoming. So this is every TCP stream, and then I am just going to do something which looks a little bit strange. You see here that our incoming message returns back a thing that includes two sides. One is it's a result, which encapsulates a TCP stream, which is what we really care about, and an error, which might represent things going wrong. So how do we so we can do two things. Let's say we have a connection that's flaky and closes off. We can either report this back, or we could just say, for right now, we want to ignore that. And so I'm going to ignore that by just flattening. So this will skip any connections that have problems and only bring me back an iterator that represents a valid TCP stream. And now our TCP stream, we need to convert into a request. And because this represents the read side, And we could say, like, we could also just say sort of it's from a stream. What I'm going to teach you now is a whole bunch about error handling in Rust. And I hope it's going to be a lot of fun because, so we have some new thing. Does the incoming block, so this is an interesting question. Does this block the current thread? At the moment, we don't, yes, it will block. We haven't, so the main thread is listening for connections. We have not created a worker thread that is responsible just for handling the connection portion of the TCP connection, if that makes any sense. But we aren't doing any communication. We're not reading any bytes from the stream. We're just setting up all of the sockets. We haven't read from them. We're going to be doing that now. And I'll just say this is a new request coming from an incoming stream. And we're going to return back a request. Our job now is to do a lot of parsing. And so to represent, but however, unfortunately, our TCP stream is quite flaky. The client might just like vanish. Their computer might just shut down. They might be on mobile and the battery ran out. And so we need to be able to represent the fact that things could go wrong here. And the typical way to represent errors in when we relate to what is known as input-output or I/O is that we return back what is known as an I/O error. And in fact, this is an I/O result that might return a request. In fact, we can just say that it does return a request. So it can satisfy the type system. We're not doing any work with, but in fact, I'm going to change this to do. The to-do macro will immediately panic once it's hit. So but it will satisfy the type system, which is really, really it's quite a handy trick. And so there's a question that has popped up. Are you streaming to Twitch as well? I am streaming to Twitch as well. So this is actually going to LinkedIn, to YouTube, to Twitch, and to Twitter or X, all at the same time. I'm using a piece of functionality, a thing called StreamYard, and I've got I can actually share like a referral link if you want to do your own streaming. But we can talk about this, like have a meta discussion about the stream, potentially at the end once we've got through the code that we want to write. Again, I really am ecstatic about how much participation that we're getting. Let's talk about. We need a few things. One is our request needs to have a version. And for the moment, I want, and so I'll just create another type, HTTP version. And it's kind of not really relevant to us right now. So we say it's 1. Actually, I'm actually going to skip the version, and just because this isn't really relevant. We're not going to change any of our behavior depending on if it's sort of 1.0, 0.9, 1.1, and then there's 2, and then there's sort of things like quick. Essentially, we're going to skip all of that and just assume that if you are above 1.1, we don't know how to deal with you. And we're just going to treat you as though you are 1.1. And luckily, the backwards compatibility, hopefully it all works. We do care about the resource. So the resource is going to be some string. Preferably wouldn't be a string for reasons that we'll talk about soon. So this will be something like represents represents. You may have heard the term route. in your URL that you're looking in your web browser right now, you'll see a slash after the domain name, and everything after the slash is in fact, including the slash, is actually part of the resource. And one thing we do care about is the method. And so let's create a specific type for that, and I'll create an enum called HTTP method, and we'll have get, post, put, delete, just to demonstrate that there are multiple things that a web server can support. Our code isn't actually going to do much of that. We're really only going to support get method to, let's say, a couple of different resources. There's an interesting question. Why are you using triple slashes? This is and like this seems like a bunch of things. This seems like this is quite a stupid idea. Doesn't make any sense. And there are multiple reasons why I'm using triple slashes. One is that if I go into my stream train and execute cargo doc / open, the code that I am producing will automatically create HTTP documentation that includes the text that I've added in with 3 slashes, but will exclude the comments that I've included with 2 slashes. So 2 things are happening. 3 slashes indicate that I am creating documentation that will be there for the end user. Or for actually in this case, not the end user, the programmer who's going to be using my framework. The primary reason, though, that I am including comments when I am talking is that most people listening to this stream do not speak English as a first language. That means that having some text to anchor what they're listening to means that they're going to be able to follow along. So the primary reason why I'm using triple slashes right now is that I am is that I'm trying to teach. Okay, so we've got a request and then we have a body. We need some headers. And our headers are going to be, I'm just going to create a type alias. So this is another functionality for, let me show you something that looks quite ugly, and we'll show you why I want to use a type alias for it. So the way to represent headers is another decision that you as someone who is interested in algorithms or data structures is going to really worry a lot about. The specification allows for lots of variability, or the problem is that people that write HTTP often do it badly. And we also want to have something that is high performance. We are mapping between a name, like content type. So I'll show you an example of so this here is a header. The first line is something that we've seen as special. And then after the first line are these header rows, and we've got content type where I describe the content that I'm responding to and responding with. And it contains some what we might call a key and a value. So we're associating some string or some text with a value. Like content length here, we're saying is 37 bytes. And however, it's illegal from the point of view of the specification. But it's possible that someone might actually have multiple instances of the same header. In fact, there are some cases where this might be, so it doesn't quite make sense. Wow. it makes it very difficult to decide what to do if you just map between 1 and 1, like between two things and so I'm going to skip that by allowing users to specify the same header twice, and we're going to collect that all into a string. And now the body is a special, I'm going to use string here, but because we expect that the request is going to be a string. However, I should really keep it as the TCP connection itself, because every single string that I create, and this is for people that every single string that I create is a new memory allocation. And you can see that I've highlighted many things. And this demonstrates that I'm creating several memory allocations, which strictly speaking are not necessary. So if you are creating a very high performance web server, you need to minimize the number of memory allocations as you go through. And one nice thing, or at least I say it's nice, is that your request no longer cares about the TCP connection. Essentially, I don't need to know about it anymore. So we start with the TCP stream, and then we get back our request. I might find ourselves, actually, I'm going to change this to take a mutable reference to this stream. In fact, I might show why I'll do that later. Let's just create a request, and then I'm going to show the limitations of the method that I've created, and explain why I might need to change that later. So we've got a really difficult thing on our hands. We need to create this request object, and from a TCP stream. TCP stream it represents bytes that we don't actually have access to yet. They have still sitting on the other side of the network. So I want to introduce a little bit of indirection, and that is I need to show you how to read from we need to show you how to read from the network. And we saw it before. We had this buffer thing, and I'm going to change the type of buffer. Which, instead of having a fixed array, which is what the example code had, which will once we fill it up, there's nothing more we can do. Instead, what I am going to do is have a vector, which allows me to grow at the expense of some slightly increased amount of overhead later on. And for reasons that we can do this manually. So I could copy my example code across. But this won't be as nice as I need, because I want to distinguish between individual lines. And so therefore I should create some sort of helper method for being able to read a line. And so here I go. I'm just going to copy across my cheat sheet, and then I will actually I will do so. I'll just make one very small change so that I don't terrify you. Rust can be extremely complicated while you're learning. And if you are not sure what is happening, you have a lot of sympathy from me. So you see here, so I'm copying in a new the refactor function saying read header line, which takes as an argument a stream, a TCP stream that has mutability, which means that I'm able to update the inner state of the TCP stream. It returns back an IO result that contains a string. Now let me show you how it works. The squiggly lines are a little bit angry at the moment because I have actually deleted some necessary code. So we start by creating a buffer again, and this is a 4 kilobyte buffer as long as my hex is valid. And from the stream, I might just pull all of this out so that no one is distracted. We start with stream, and then we ask for its bytes method. And I'm just going to add the to do macro to silence a lot of the angry, red lines here. Okay, now bytes returns. Oh, I need to bring in a trait. So one of the annoying things that you'll find is that your code might fail inexplicitly because you haven't brought in traits that are dependent, that your code depends on. So if you copy example code from some other location, you need to also ensure that your imports are also copied across. Now bytes is in scope. And I'm just going to check, there's another one as well that I need to bring in, which is I also want, so the read is a trait and write is a trait, which will be handy later when we come to write things. And so I now have a bytes method on TCP stream, which will bring me back an iterator of bytes. And now I can ask for the very next byte. And if this is something that I know about, like a new line character, then I am done. So, except I don't just get a new line character. What I get is an option, which says that there might not be a byte to read at all. There might be no next byte. And if that is the case, so I can match. Let's actually just do it by, if there's no byte, that means essentially something really bad has gone wrong. And I could return back an error. So I could return back, essentially we have received back something which, has been, I'll show you how to do this. This looks complicated, but we have a couple of inner types. So if we have none, we need our IO error is IO error new. And then we need to give it a kind, which is IO error kind of connection aborted. And we want a message saying client aborted early. So this is the type that we are going to send back, and we need to wrap that in what's known as the variant of result. See, our code here returns a result, and even though it's not visible, the error side or the side of this is essentially an IO error, which we're producing up here on line 52. Otherwise, we have some byte, or at least we have something, and it might be a byte. In which case, this is our happy path. This is what we really want to see. So we'll just leave that as something that we really care about. Or there might have been some other problem. We might have actually received an error ourselves. So we might have received some error message, and in which case we could actually just return back the error. And slightly awkwardly, I need to unpack it with this pattern matching, or and then essentially repack it in another error straight away. But because it is already an IO error, I don't need to perform any conversion. This all looks very ugly. We're going to refactor it very, very soon. What I want to check is if this byte is equal to the new line character. In fact, it's the new line byte. So this is an ASCII new line. Then we are finished. Then we return back our header line. Now we still have a problem. Our header line is some string that we need to kind of fill up with. In fact, we need to actually do some reading. So we're not quite finished. I need to actually read from the TCP stream, convert that to a string, and return that. For reasons that will become... The other thing that might have confused people is I'm not doing this in a loop. And I want to introduce an infinite loop here, where I will continue to read one byte at a time from the TCP stream. And otherwise, sorry, buff push the byte. So finally, we're getting closer. We're actually reading into the buffer, which will automatically grow as things are, which will automatically grow as we are, as we're going. Now, there are lots of, we've actually opened ourselves up to a denial of service attack here because we have not placed a limit on the number of bytes that we can read in from the client. But let's say we're not going to worry so much about security right now. We can carry on. Okay, so our buffer is being is added up. We now need to convert this to a string somehow. And the way to do this is with the way to do this is here is the string has a static method from UTF-8, which takes a vector as input. So I don't actually need this temporary variable now. I've got my buffer, which is a vector, which is handy because that's what I need later. And unfortunately, though, this is not quite enough. I require, this is another result. So this conversion step may fail because I don't know what the end user and what the client is actually sending me. They could be trying to fuzz my server. They could be sending arbitrary bytes that and so I need to map the error that is generated from the string from UTF-8 method into an IO result. So this is what the map error, the map error method does. It takes an error from one form and converts it into another. And I need to say, hey, this client, it's not a very friendly client actually. It's actually sent me some invalid data. So I need a new error value, which as its kind, sort of the internal variant is an IO error kind, invalid data. And I could say as a message that not an HTTP header. I am only using my read header line method during this during the process of creating a request object. And so I know that it will only be relating to header lines. And you could say non-UTF-8 a invalid. We'll leave the message there. And now the error is almost the same. Except, well, so the header line still hasn't changed, except we're passing in a new error. I can now introduce some new syntax, the question mark, which will propagate up what I have created into the caller's scope. Header line is almost enough. I now need to say that everything was okay, and I can now read one header line. Now, this is some horrifically ugly code. I was going to say, this is some horrifically ugly code. And we've just had someone come back and say, oh, isn't it so beautiful? So clearly our aesthetics are different. I want to do some very quick refactoring because we can actually do much better than this. I think we can be a little bit tricky. Allow me to refactor the code. And in some sense, you really shouldn't bother with refactoring with example code like this. However, we're trying to show off some of Rust, and so allow me to make it even nicer. So I can actually introduce some new syntax, which is while let. And so while will loop as long as a condition evaluates to true, and let introduces a pattern. And what we care about is some pattern, some okay, whereby we will go and read our bytes we're reading one at a time, and if we get to the end, something interesting has happened. It means that we never detected a new line character, and so therefore we've actually detected the error state. So this portion of code right down the bottom is actually indicative of a problem, because in here in our while loop is when we get to return early. So we do all of this stuff whereby we create our new line and then we return it. Ignore the formatting for now, I can fix that. The other thing that I just want to change while I'm here, while I remember, is that buffer will also include a carriage return character as well, just as part of the specification that, and I could just check if buffer ends with a specific byte, which is the carriage return, then I can get rid of it because it's not necessary. Yeah, you can do whatever you want, but we're returning early. So if we get to the end of the while loop, it means we've actually encountered a problem. We're still doing our nice thing of being able to return back from our invalid data. So we haven't actually lost our code. We have lost this case, is that if there was an error, so arguably the loop is actually better, but I wanted to show that there's something else we can do. Oh, unexpected. I expected a slice and found a character. Oh, okay. So this type, so here is something else we've found discovering about Rust. Mismatch types, and it's saying here, I expected an ampersand brackets U8. What? Found a char. What is this? Allow me to fix it, and then I'll explain what the problem is. And this may not be obvious what I am doing, but I'll start with changing the quotes. single quotes mean that you are telling Rust about a single character. So this is the char or car type, depending on how you pronounce it. But the square braces indicate some slice of bytes, so at least 0 or more bytes. And the way to provide this to Rust is with the double quotes. Now, if you just use it naively, you are going to get an error message. In fact, with some helpful diagnostics saying that you should prefix your slice with a B, which indicates that you are just giving it raw bytes. You're not providing an encoded string. Okay. There's another thing we could have done as well. We could have actually used the literal form of, so here it's a slice of 13. If I wanted to, I could say that instead of providing the syntactical escape form of the carriage return, I could provide the literal ASCII value for it. But this is significantly less readable for people that don't know what is happening. So this is fine. And why is this angry at me? Oh, it's angry because I have got a semicolon right at the end, which is changing the return value of the last expression from the error that I am generating to unit. What is the terminology used for the last, for essentially nothing. Every expression in Rust returns a value. The return value of the semicolon is unit or is nothing. Okay, now we have read header line. I can finally go back to my request. So this is kind of this horrible code that we started with, and we want to be able to read our, instead of having to deal with all of the reads ourselves, I'm just going to comment this all out. And then the first thing that we need is the HTTP metadata. And this is, we can read header line, and then we get a reference to our stream. And I'm going to use the question mark operator, which will propagate up the error code. The HTTP metadata will look like something like this. It will, and in fact, I can actually, it will say get a slash and then HTTP slash and then let's say 1.1. So the very first line we need to break apart into three different slices. Three different parts. We have the method, the resource, and the version. So one of the ways to do this is to so HTTP metadata is just kind of split. Now split is something that might feel counterintuitive. So we want to split on white space. And we aren't worrying about all Unicode variants of white space. We actually only care about single spaces as long as people are being compliant with the specification. We can even simplify this down even further. Split ASCII white space does not return you back a list of things. It returns you back an iterator. And I want the method. It will be the very first instance of our iterator. It returns back an option, and then the next one is the resource. And lastly, we have the version, which we're actually essentially going to skip because we decided not to bother with it in our definition of request. For various reasons, we're not going to change any of our behavior dependent on the version. Though now, I mean, we could say that, but we might not. Okay, so our method. Let's talk about, so we want to be able to, we've got a problem, and that is we have this type, HTTP method, that has something that looks like the actual the text that we see, except it's not a string, it's an enum, and so we need a conversion step. And you can see from the type signet or the type hints that this is actually an option. And so method. Let's do something interesting, which is unwrap. So we expect that this is going to be the case. If it's not there, then there's a problem with the actual, we could return invalid data. We could say that actually this is not really an HTTP call, but let's skip that for now and say, and that we can match method on string literals and say that if this is going to look quite boring and relatively routine. Here we go, get, and we can kind of do the same for post. Put. There's no one, and also lastly delete. I am doing this in order because I think that because Rust will go from top to bottom, and I think that get is the most common, and then post, and then put, and then delete. Potentially, it's probably something like this. There are more sophisticated parsing algorithms than naively doing what I'm doing here. In fact, I don't even need to essentially, but this will be fast enough. And now I want to reassign method. Which is now an actual type. I can do better. I don't actually need the temporary variable. I say better. This is arguably not better, just in terms of slight refactoring. I can get away with the temporary variable. Potentially here, if I get something else, anything else at all, I might want to return back an error that is an IO error new. This becomes quite tedious at the moment, and just say invalid data and say unsupported. So someone has given us something we don't actually know about, we don't understand. We could do the same thing for the versions if we wanted to, but we're not going to bother. The resource we do care about, I'm going to unwrap, and then I want to do something extra, which is actually convert the string slice, which is a reference to some span of valid bytes, to a string. We incur about 20 nanoseconds of performance problems because we actually need to go and allocate space for a new string. This is also not super necessary because you could use intern strings. There's a whole lot of optimizations you could perform. So this is essentially the slash, and this might be index.html. And another way to do this would be to say that this here is the, this is probably obvious to everybody, but this is the method. And I'm going to get confused because I'm doing this. I'll do it the other way around. I'll start on the left. So this is the version. This is the resource. And over here on the left, we have the method. So now the resource we really do care about, because we're going to sort of create some functionality for dispatching some behavior dependent on the resource. So if our users ask for index.html, we want that to mean something. So we really need to hold on to that. So I'm going to convert it to a string. Now I've got something extra to do. So resource, I need to actually create the request type. So we've got resource, method, headers we don't yet have, and we don't have a body. So let's carry on with this process of parsing the request. I now need to, what do I need to do? I now need to create some headers. We talked a little bit right at the beginning of this whole process of saying that there is lots of opportunity for us to think about the different implementations or the different ways to represent this data. And I am going to create a type alias, which is headers. And it's going to be in fact, it's just going to be headers. And this will simplify the code. A type alias does not actually define something new for the type system. It's purely there syntactically there for your source code. And now I have headers new. Oh, I pushed the wrong button there. I need to make sure that this is mutable. And you can see it's a hash map. And we want to be able to go through the rest of the line. So it's in some sense, it's for line in read header line with the stream. If line is empty, we now break. Except this doesn't quite work because read header line is not itself an iterator. It doesn't return back an iterator of lines over the stream. So I need to change the code slightly to introduce a loop. Alternatively, I could have used my while pattern again, but it will be simpler like this. So I'll plunk that in there. I've got a loop, let line. Multiple cursors decided to jump out on the screen. And let line, so this is no longer a loop, it's an assignment, or formerly known as a name binding. So if the line is empty, we have finished the headers. So one of the interesting things about HTTP is that an HTTP request and an HTTP response have a uniform format that essentially has three different sections. The very first line is the metadata about the rest of which is the one that we've been dealing with the most, has all of this metadata about what the request looks like. Now, after that are a series of headers, and we've decided that we're going to allow users to break the specification and provide the same header twice. For when we detect that there are the delimiter between the headers or between the metadata and the body is a new line character. Hello. And the new line character, sorry, is an empty line, essentially. So once we find that empty line, everything following that is the content. We have a slight issue in that reading the line might actually be a problem. So I'm just going to ignore that by using the question mark operator, which will jump the error into the parent scope. And if line is empty, we break. If I hit save, we should, okay. I know why so this is a little bit confused. It's saying that there is some, I'm not returning the right thing. So I'm just going to add to do right at the end. There is another problem. I need parts to be mutable by sort of skip that. So now I need to like build up this hash map. And the easiest way to do this, although I still think that many of the people in this chat or this our little group of us will actually know a better way to do this. So here is your chance to shine. Here is our line. We're going to split it, and we're going to look for a colon and a space, and that is going to be the difference between the left-hand side, which represents the key and the value, or at least the header name and the header value. I'm going to do something which I don't like, but okay. So let's say we have the header name. So this might be something like content type. The capitalization has changed in recent versions of HTTP. In HTTP 2 and 0 and beyond, it's all lowercase, which I sort of weirdly disagree with, but okay. So this will be content type. And we take parts and we call next, and then we unwrap it, expecting there to be an actual header there. We already know that the colon and the space exist. So therefore we expect that there must be something on one side of the lines. Actually, that's not quite valid, but let's say we call unwrap, and then I promote my string slice to a string. And then on the other side, I am going to say value. And this might be text HTML. Okay. I'm going to introduce some syntax here, which is going to look odd. And I apologize for that. But one thing we want to avoid is looking at our hash map and checking, does this thing exist? And if it does, then insert a blank value. And if it doesn't, then add to the old value. I kind of want to do this in one go. I don't want to have to create multiple. I don't want to have to do this twice. Now, by the way, you should feel like this is not, just to be very, very clear, you do not need to create a string here. If you wanted to go to the HTTP specification is fairly well defined. You could create enums, which are represented just as integers internally and are quite efficient. Go to the trouble of creating some sort of parsing logic that looks a little bit like what we've done with the methods. Entry. We want to check whether or not the thing exists. So we're going to say, does content type already exist? And if it does, I then want to so if it does, I then need to like add it to the list. But if it doesn't, I need to provide some sort of default behavior. And that default behavior will be, please execute a function which I'm defining in line. The vertical bars there indicate an anonymous function, otherwise known as a lambda function. And there will be a vector and has a static method. And I'm going to ask for a vector with capacity of 1, which sounds like a very odd size. But by default, if you just ask for a new vector like this, Rust will not actually go and ask for any data to be allocated. It will give you back something with 0 allocations because it wants to save you time. In our case, we know that we need space for at least one value. So we may as well do that up front and save and essentially reserve capacity for the value that we're going to insert in the very next line. So this entry and then insert is actually going to ensure that there will always be something, there will always be space for our for our value. Oh, I just pushed the wrong button again. Jumped around. Unfortunately, we get back a very odd looking type. By the way, I have not received very many questions, and I assume that, and I've been monitoring the chat window a little bit, and I'm not seeing a huge amount of people saying, whoa, 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 please stop. Now, does this mean I'm doing fine? If it does, that's perfect. If it does not, that yeah, please allow me, please ask me to stop and explain things if you need. Okay, value. What do we need? We need to insert the actual thing. Now, the type that this is, no, actually, this is the wrong variable name. We are well-behaved students. That's thank you very much, my dear students. I appreciate this great deal. Okay, great. Okay, value is not a very good, is not a very effective. I've used value in multiple places, so this is immediately, I need a different variable name. Here it is. I'm going to put this as like a slot for value. So I got some space where I could insert or push our value to. Now it has a very strange type. You see it's this ampersand mut or MUT, mute, vec string. It actually is a pointer into the hash map itself. And then I can immediately call methods on a pointer to a vector as though I had the vector directly. One of the interesting, quirky things perhaps about Rust is that when you have a reference to an object or a reference, let's say a type, or reference to a type, in our case we have a reference to a vector, Rust will automatically, what is known as dereference the type. So if you were using C, you would probably need to use parentheses or braces to make it very clear what you're doing, and you'll use this star to go to the inside of a hash map and bring back the vector and then call push on the thing. We're not doing that here in Rust. We are asking the compiler to do it for us. Now, at the end of this loop, I have all of my headers. I have my method. I have my version. But I don't have my body. So there's a choice for you as the designer is whether or not you ask your clients, you do the read. So you need to decide whether or not you are going to just store the connection and incur the cost. Sorry, other way around. Let me show you the type, what I'm talking about. We have a couple of problems. One, users could be uploading they could be uploading an image or a PDF. That makes no sense to be allowing the body, requiring the body to be a string. So at the very least, we actually need to provide some type which is not guaranteed to be UTF-8 because they can be sending anything they want. That's the whole point of this thing. The problem with doing this, which is in some sense the easy way, is that you now require lots of extra work to happen before the request handler can perform any business logic at all, which is in most cases is going to have nearly no impact on performance. But if there was a very large upload, I now need to and there's a question, are you going to handle HTTP methods that don't have a body? That's a really interesting question because, for example, we could say delete doesn't have a body. We could also have there's another one which is the head the head request does not have a body. So this actually should be an option of a vec of U8. And in fact, you might think that there might be one of the questions is, what's the difference between an empty vector and an option of vector? The thing is, there is a very significant semantic difference between a body of length 0 and no body. Which sounds absurd. But let's say that your file that you're uploading actually has no content. But we're still actually indicating to the user. And then there's this question, could you do a stream like this but building a database of vector database? Yeah, sure. Yeah, sure, I can just implement a database. Aha, actually, I'm just going to do a very, very quick plug for my book. So this is my book. Inside chapter 5, it's just called Data in Depth. We go and we build a database. I'm actually talking to the publisher right now to see if I can stream my revisions to the book. I'm doing a second edition, and so I'm going to be doing a read through of the whole thing. And anyway, yeah, we can do more streams. That's absolutely fine. Please subscribe. Otherwise, if you don't hit subscribe, you'll never find it. Okay, let's finally get this request passed. We're deciding that what we're going to do is read the whole thing into RAM. This causes significant risk. We could expose our service to denial of service attacks. There's a whole bunch of problems. And there was a question very early on, wasn't it? Isn't reading 1 byte at a time extremely slow? And in fact, so I do this thing where I stream bytes next. And in fact, it is. It's awful. It's really, really bad. The reason why it works is because I am only doing this for a very short amount of time while I'm reading the header. For the body, we can't get away with reading 1 byte at a time. This is going to cause I was going to start swearing on stream. This is going to cause a lot of problems. In fact, we can do better than this as well. I'm going to introduce a new type. So we have here standard IO read and write, and I want to introduce buff read and buff reader. This provides what is known as buffered I/O, which asks the kernel to actually maintain the buffer itself, which actually I should double check whether or not if the kernel has the buffer or I have the buffer, it doesn't matter. We reduce the number of syscalls involved in reading from the network socket or from the disk. And when we're reading the body, because the body could be very, very large. I need to actually send the stream in. And I'm a bit concerned that I'm going to cause myself a lot of grief here. And I'm actually probably going to have to backpedal from this. So I'm going to say that I now have a buff reader of TCP stream. You know what I want? We could get around this by requiring that our argument is actually strongly typed as a buff reader of TCP stream. It provides exactly the same methods, except for the fact that everything suddenly speeds up from our perceived, so this now moves from buffer reader stream into the connection handling. At some point, and this is obviously, we're actually running well over time, I could actually do this flatten and map and stream and then buffer it a new stream. And this is stream. Okay, so that's going to be great. Except for the fact that I now have I'm introducing a new problem. So we now no longer need to, we now need to stream read to end. This causes us a very big risk of denial of service attack. So I just want you to know, if you're in the business of creating your own web framework, do not allow your users to send in arbitrary amounts of data. They will send you gigabytes of data, and this will crash your entire server. Let's say though we want to have width capacity of 10 megs. Let's say we have some arbitrary body, and we'll start with I don't know. I think this is 1,000 in hex is 4 kilobytes, and so 10,000 in hex is should be sufficient for most requests. Now we want to be able to say body. Now this is needs to be mutable, and this is not going to be. We need to provide a mutable reference to the body. We're not passing ownership into the read to end method. This will return back an IO result, you see here from the type signature. And so I want to be able to propagate that back to the caller if there's any issues. Now, dun 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 dun, we have enough, or at least we have enough just to generate the request. Okay, so what have we got? There is this kind of issue. It's like, well, what if there is nothing? So I need to figure out. So there is a distinction between if the problem that I am now realizing is that if it is a body of length 0, we need somehow to distinguish between requests that have no body and requests that have requests of length 0. I'm going to actually punt that to to-do. So we're going to go semantically wrong by just saying that we can have an empty body. We're not going to distinguish between an empty body and a resource is resource. When we have the variable names exactly the same as the field names, we have this shorthand method, and then here it is, it's the same. Method. I'm going to just, I want them to match up. Sorry if I'm not being as interactive as I should be right now. I'm just trying to think and the type system is a little bit angry with me because it wants a result, and I'm just returning the request directly. So I need to wrap this in OK, telling me that this request has been successful, and I now have a request. Here we are. There's my request. If there is and so in fact, I can actually do another map. So this is going to sound silly. Oh, no. if I wanted to handle every, oh, okay. So if let request is okay. Now we can generate some sort of response. And we'll just use new as well, and like from a request. Otherwise, we're going to skip any errors, and the type system is going to not mind too much. But now, so we've actually only dealt with requests, but now we have the ability to dispatch on the methods, the headers, and we've got the body available. We should be able to, if I just do this and I'll just print line and the request, and then I'm asked for the debug output with the question mark. This will fail the type system currently because request does not implement debug. Oh, there's a whole bunch of errors up here, which is why my thing's getting a bit confused. So I can ask for the compiler to implement a few traits for me. So I'm going to ask for it to implement debug, which is going to allow me to have this kind of debug output. And then debug out is going to say, oh, HTTP method doesn't implement debug. So there's no point in doing that. And now the type system, sorry, now if I, oops, my type hints are saying that I should really go use the shorthand notation. And down here, I have a compile error. This file contains an unclosed delimiter. Uh-oh. So I've got a typo in here somewhere, and I'm going to ask Russ to help me find it. I have a suspicion it will be in, oh, there it is. I expected a TCP stream, but I found a buff reader. Okay. Now, I could do one of two things. One is I could actually ask Rust to no longer care about the specific traits and instead use things I could ask. I could use generics, but now. For the moment, I am going to ignore that. And I just want to double check that I'm actually reading this. Oh yeah, so stream bytes next. Okay. I'm getting some I'm just changing the types around because the buff reader type requires a different type to the one that I have specified. Now here is where the thing we haven't actually detected. Let's get this thing to run and see if I can. Okay, it builds. Woo! Yes! We're only several. I don't know people's obsession with writing everything in Rust. It's such a stupid language. I don't know people's obsession with coming into streams and then just commenting stupid comments. It's like what's the point? Like, you're only going to embarrass yourself by, literally, you're like. What a weird thing to say. Go find your own stream. Create your own stream with your own language. Go away. I honestly don't have any time for you. Cargo run. Okay, cool. Localhost 8080. Empty reply from server. Aha. That's almost that is almost what we want. Thread main panicked at in fact it's nowhere close to what we wanted. What has gone wrong here? I need to start by unwrap on a none. So essentially, we started with reading the line and we got no. We didn't get our metadata. So what I want to do is introduce some debugging. We can use a real debugger, but I'm going to skip that for now and use the error print line, which asks Rust to print to standard error instead of standard out. Oh. Cargo run. And down the bottom, I'm running curl. This is going to connection failed. Oh, there's actually, so I panicked, which means that the actual server crashed and ugh. So there's an empty line somewhere. That's interesting. Because the curl has actually sent back like exactly what is required. There's our get, there's the method that we are looking for, the resource and the version number. And that means that there must be a bug in my read header line code. It's sending me back an empty line. I just need to change. And we don't want an empty line to start with. But why is it sending me back the new line character straight away? Oh, you know what I'm not doing? I'm actually not expanding anything to the buffer. So of course it was going to be empty the whole time. Right. Okay. So now our super server might be able to serve content. We'll see. In fact, we can't quite serve content yet. We can only really we've got headers parsed. We've got some wild, we're not Rails yet. In fact, Rails didn't do this. Rails didn't have to worry about parsing HTTP requests. I'm pretty sure that was dispatched to some other part of the Ruby. But this has been kind of fun, hopefully. Cargo build. The code builds. Cargo run. Aha. It's working. Hold your breath. There's the method. There is a problem. And that is we are continuing to read. We're continuing to this is down here when we get the body, we say read to end. That's actually not what we want to do because there's no end. The TCP connection will actually go and continue to we'll just continue to wait. There's nothing there for it to do. So we need to change our business logic slightly. because if we want to be able to read to end is not quite what we want. And I'm just going to change this to read. Now, we should see the read amount is not handled, read exact or handle partial reads. And so I get this warning from Clippy. And you're like, well, what on earth is Clippy? Clippy is a linter. And Clippy is a better programmer than I am. So allow me to show you what Clippy is. Clippy, I'm just searching off screen. By the way, I need to actually start to get ready to wind down the stream. We are obviously not at the stage yet where we have a full implementation of a real web browser. So please subscribe so that we can actually get this done in a future stream. I try to stream around about this time because it's quite nice for most of my audience to come on Sundays to learn a little bit of Rust. Cargo, so Clippy is a linter. It checks your style, and one of the things that it's asking is saying, if you really meant to read, then you're doing the wrong thing. And we get an indicator. If we go to the link, it's saying that you must be doing the wrong thing. And what I'm going to do is ignore the problem with this underscore, saying, actually, I'm going to tell the compiler that I'm going to care about it, at least I'm going to tell the linter that I'm dealing with it, but I'm not going to deal with it. Okay. Let's see, though, if we can actually read the response without stalling. Last time, we weren't able to even get what we need. Again, hold your breath. No, we didn't get there. So we actually find that there's a bunch of sophistication that we need. And one of the things that and so this is interesting. I did the interrupt, Control C, on the side of the curl command. And you can see here that I was actually able to get to 136 on my server where I printed out the request. And this is the material that I received. I received a resource, the method, the headers, and then there was no body provided by the client. There is more to do to get our code actually working. But I think this is it keeps yeah, and there is actually a way. So there's I keep wanting to stop, but people have some really wonderful suggestions, and I want to show you how to add this. One of the things you will know if you have done anything with asynchronous AO is that you do not really have the ability to interrupt a thread. However, I can adjust some. So once we have server, we must have a connection. Otherwise, we would have failed. That's what we defined. We would have panicked. And so if we go inspect and say our connection and say we can set a, where is it? We can set a timeout. And I am going to just check my cheat sheet. The method is called set read timeout, but it will only be and then I provide some duration, and then I'll say it's from seconds, and then like 1 second. So if you haven't sent me your data within a second, then I will terminate the connection. This provides you with a little bit of assurance that your code won't you won't wait forever. Now that will prevent a class of attack known as slow iris, which quite famously was used a few decades ago in the Arab Spring to be able to actually enable people on very limited devices to take down government websites. Because Apache at the time, so the predominant web server, was very vulnerable to a particular type of attack, which allowed it to maintain connection state while data was being sent in very, very slowly. Anyway, I need to be able to find the method. Oh, it's actually on stream. So it's not on connection as well. So there's a couple of things. So in here, I have a stream, and then this is starting to look quite ugly. I apologize for that. So the TCP stream has the this read timeout thing. And the yellow squiggles indicate that Rust thinks that there is a something that I can do to improve it. And now the code has changed very slightly. I'm no longer, if I run and then curl, it will abort. It will say empty reply from server after 1 second, and I can continue to send in more requests, but this isn't actually the behavior that we want. We're not sending back a response. Oh, that was never going to happen because we never got to the point where we're sending responses. We're still having an issue with the stream not being read correctly. So there's a little bit of work to do to get ourselves in a production state. But I'm hopeful that the last hour and a half or so has been really informative for showing you how to work with text in Rust, how to work with data coming across the network, about error handling. If you've been able to stay with us for any amount of time, then, or with me, I suppose, then you are doing extremely well. And I encourage you, if you can, to continue your work with Rust. I am going to start to wind down and say goodbye. I really love this. I really, really enjoy these streams. So all of the suggestions that you are providing around different topics, I've seen you should implement a web service in WASM, which seems like a very cool thing to do. And I also want to show off the Servo web browser, and there are lots of other little projects. Please do find me on YouTube. It's probably the best place. And again, the code will pop up in my GitHub, and here is my YouTube link. Go in there, hit subscribe. You'll be notified for new streams and videos. It makes a huge boost when everyone has been as enjoyable to it makes a huge boost that everyone has been as interactive. And take care. Be well. My name is Tim Clicks. I'm on the planet to build a better planet, and I will see you later. Take care, everybody. Goodbye.